In this video, we will be looking at the last way to graph quadratics, and that is when they are in standard form. So today we are focusing exclusively on graphing quadratic functions when they are in standard form in the equation. So let's get started and look at the formula. First, when you have a quadratic equation that is written in standard form, this is the formula that it's going to follow. Notice that this one looks a little different from what we've done in the past. You have an A value, a B value, and a C value. One thing that I want to point out right away is that this A value is not the same kind of A value as what we have been working on with intercept form and vertex form. So be very careful here. A, B, and C are different. So important things to note about this formula: we are going to be using the A value and the B value in order to find the x-coordinate of the vertex. And it's also going to tell us the axis of symmetry by using this guy here. X is equal to negative b divided by 2a. We're going to plug in the value for b, we're going to plug in the value for a and simplify this, and that will tell us where our line of symmetry is and also where part of our vertex is. So let's look at an example of that really quickly, just working with this formula for the x-coordinate. So if you're given this problem, y is equal to x squared plus 2x minus 3, then we can use this formula first to find the axis of symmetry. So to do that, we have that x is equal to negative b over 2a. B in this one, A, B, C, is positive 2, so this is negative b, which is 2, over 2 times a. Now the a is the coefficient out in front, this lead coefficient. There's nothing there, so that's like multiplying 1 times x squared. So we're going to put a 1 in there for the a. So that means we have negative 2 divided by 2, which is negative 1. So the line of symmetry then, you can see is drawn here where x is equal to negative 1. Now, in order to find the rest of the vertex, which is our second piece here, we already have the x-coordinate of the vertex. We know that it is at negative 1, but in order to find the y value, we're going to take that x and plug it into the original equation that we're working with. So we're going to evaluate the function at, in this case, negative 1. So that is going to be negative 1 squared plus 2 times negative 1 minus 3. Negative 1 squared is 1, 2 times negative 1 is negative 2, and then we've got that minus 3 on the end. So that's 1 minus 5, which is negative 4. So our vertex is negative 1, negative 4. And you'll notice on this graph, that is exactly where it's drawn. So let's go through now and work through the steps for finding or graphing a quadratic function that's written in standard form. There are going to be quite a few things that we have to do. I think standard form is probably the most work when it comes to graphing without a calculator. The first step is going to be to find the vertex. So we're going to use that formula to find the x value. It will also give us the line of symmetry, and then we're going to substitute it in to find that y value. So this part is just like what we were just doing. Here is the problem that we're working with. Y is equal to x squared minus 2x minus 8. So first I need to identify what a, b, and c are so that I can use those values. The a value is 1 because that's the lead coefficient. This minus 2 is the b, and c is negative 8. So plugging into this formula, x is equal to negative b, which is negative 2. So notice that's negative, negative 2, divided by 2 times 1. Negative negative 2 is positive 2, and 2 divided by 2 is 1. So the beginning of my vertex is going to be a 1 for the x-coordinate. Now let's find the y-coordinate. We're going to evaluate our function at the point 1 for that input. So we're going to plug in 1 for each of these x's. That's 1 squared minus 2 times 1 minus 8. So 1 squared is 1, negative 2 times 1 is negative 2, and then I'm subtracting 8 off of the end there. that is going to be 1 minus 2, which is negative 1 minus 8. Negative 1 minus 8 is negative 9. So my vertex is at 1, negative 9. Now the second piece after I have found my vertex is to complete a table like what we were doing with the vertex form. So I'm going to put 1, negative 9 in the center of my table. And now I'm going to pick some x values that are nearby. So I'm going to pick 2 and 3, and I'm going to go the other way, pick 0 and negative 1. Remember, the symmetry here means that we're only going to have to do half of the work. So let's pick one side, either the left or the right, to plug in to find the y values. I really like zeros, so I'm going to pick this one to work out first. I'm going to evaluate the function at 0. So f of 0 means I plug the 0 in. 0 squared minus 2 times 0 minus 8. 0 squared goes away, minus 2 times 0 goes away, and it leaves me with negative 8. So that y-coordinate is negative 8, and this one is symmetrically negative 8. Now let's pick f of negative 1 to solve next. So when we plug negative 1 in, we've got negative 1 squared minus 2 times negative 1 minus 8. Negative 1 squared is 1. Negative 1 times negative 1 is positive 2. I'm sorry, did I say that wrong? Negative 2 times negative 1 is positive 2. And then we're subtracting 8. 1 plus 2 is 3. And 3 minus 8 is negative 5. So that fills in the rest of our table. Notice at this point that we can now graph all of our ordered pairs. Our vertex, as we said before, is at 1, negative 9. Keep in mind that is also your line of symmetry at x is equal to positive 1. So everything's going to match on the two sides of it or be mirror images. At 2, it's negative 8. And at 3, it's negative 5. At 0, it's negative 8. And at negative 1, it's negative 5. Which means I have a nice little graph now, like that for my parabola. Okay, so let's answer a couple of questions here based on what we've got. Your y-intercept, notice, was at 0, negative 8. We found that on our graph down here. One thing that I want to point out relating to that, do you notice anything relating this y-intercept to the c value here? Do you see that they're the same? The c value is always going to give you, in standard form, the c value is going to be the y-intercept. So if you have standard form, while it's a lot of work to graph, at least you have this one nice piece of information. And if I go back one more slide to the top of this page, you may want to write that up here where the formula is. The c is the y-intercept. Okay, so now let's think about our axis of symmetry. That's that line, x is equal to 1. And this one has an absolute minimum where we are at y is equal to negative 9. Okay, so on the back of this note sheet, there's a problem for you to try. You should now be able to graph an equation that's written in standard form if it is a quadratic. So give that one a try.